All right, everyone. So we've just done our orientation activity, and now we're going to look at the zero index. We are stage 5.1. You guys are year 10s, and my name's Caitlin, in case any of you lovely students have forgotten. So where this lesson fits in with our unit, as it's lesson 4, you can see I've got this red circle around it. It's zero index and expressions with the zero index. In the past 3 lessons, you've learned about your index laws from stage 4. You've simplified the algebraic expressions with the product and the power rules, and then you've also looked at the quotient rule as well. So the assumed knowledge for this topic, for this lesson, is you know your terminology: base, index, power, product, quotient, zero, numerator, denominator, pronumeral, multiply, simplify, etc. You all know your product law, your quotient rule, and your power laws, which are the power of a power and the power of a product. You know your order of operations, which is BODMAS, and you recognize that division can be written as a fraction. So coming on from our quotient rule, we know how to do, for example, 5 to the power of 7 over 5 to the power of 5. You just minus the powers and you've got your answer, 5 to the power of 2. But what happens if we divide 2 indices with the same base and the same power? Does anyone have any idea?
Equal to 1?
Oh, wow. You're ahead of the game, Lily. Good job. So we're going to look at an example and then see how we can get to your answer, which was equal to 1. So our first example on the left is 5 to the power of 1 over 5 to the power of 1. We know that 5 to the power of 1 is 5. So that means we've got 1, because 5 over 5 equals 1. So great job, Lily, with that one. What about 5 squared over 5 squared? What would be on the numerator?
25.
Yeah, and what would be on the denominator?
25.
And we know that 25 over 25 is equal to?
1.
Great, it's equal to 1. Good work, girls. Super, super good. So what does this all mean? Or can you girls see a pattern that's happening here?
That if you have the same number on the numerator and the denominator, you get 1.
Yeah, so very, very close. If you've got the same number on the numerator and denominator, and you also need the same power on both of those. So here we can see that both equations equal to 1. The lingering question is, what about questions such as 32 to the power of 464 over 32 to the power of 464? How do we figure these out? We can type it in a calculator, but that might be a little bit more of a process. So let's see what happens when we use our quotient law to solve these types of index questions. We're going to do 5 to the power of 1 over the 5 to the power of 1 again. What would we write out using our quotient law?
You do 5 to the power of 1 minus 1.
Yeah, great. So we've got 5 to the power of 1 minus 1. And what does that equal?
5 to the power of 0.
Great, good job, 5 to the power of 0. But from before, we found out that 5 to the power of 1 over the 5 to the power of 1 equals 1. So that must mean that what we've highlighted in blue and highlighted in yellow is the same, which is crazy, right? So I've written a therefore. These two are equal. So let's check with another example. 2 to the power of 4 over 2 to the power of 4. What would we write out for our numerator and denominator?
2 to the power of 4 minus 4?
Yep, so that's using our quotient law, which is just there.
Sorry.
No, that's okay. And what about our fraction here?
We'd get 1.
We would get 1. So we'd get 16 over 16, which equals 1. And then we know 2 to the power of 4 minus 4 is equal to 2 to the 0. So therefore, they're the same as well. 2 to the power of 0 equals 1. Okay, so it's really interesting to see that we've got 5 to the power of 0 is equal to 1, and so is 2 to the power of 0 is equal to 1. Now, Joyce, I see you've got a question for me.
Yeah, so which is the best one to remember what the zero index is equal to? Quotient rule or normal division?
Oh, that's a really great question, Joyce. As you have seen, we've used both to establish our zero index rule. We used our quotient law to see that a number to the power over that same number to the power will equal that number to 0, which is, for example, the 5 to the power of 0 here. And then we used our knowledge of division to find out that it would equal 1. So we popped them both together, and that established our zero index rule. So that's a great question. So, little summary what we've done so far. We've used our quotient law and our knowledge of division, and this has shown that any number x to the power of 0 can equal 1. And I've written that in words here in case you guys need as well. Let's pop on to the next bit. This is going to be a little bit more interactive. You girls get to annotate and write your own answers. So what happens if we've got a number or a pronumeral in front of the 0 index, such as here we've got 10x to the power of 0. We're going to remember that x to the power of 0 equals 1. That's our 0 index. What do you think I could write out, which is covered in the blue bit here?
10 multiplied by 1.
Great, that's exactly right, Joyce. 10 multiplied by 1, and we all know that that equals 10. So now it's your turns. I've written you all one each for you to do, and you're welcome to annotate, or you can annotate by typing as well. Have a go.
How do I annotate?
I think it's up the top in one of the toggles. You can just click, it'll be a drop down and you can click annotate.
Oh, okay, got it.
Did you find it? Great. Sorry, I've got a different view on here. Great job, Lily. You're off to a great start. Joyce, did you manage to find the annotate?
Yeah.
There you go. Great. Good job. All right, really good job, girls. I've seen that Nadine has written out the whole method, which I do really like because it gets in your brain that x to the 0 does equal 1. But Joyce and Lily, it seems that you girls are already very fluent with that idea, so you jumped straight to that question. And Lily, I see that you've got a question for me.
Yeah, does the same rule apply if you've got a negative number instead of a positive one?
That's a really great question. Girls, what do we think about that one? Does anyone have any ideas if the same rule would still apply? No ideas? That's okay. Let's do an example. How about that? So let's try negative 4x to the power of 0. What would I do first? As Nadine did before, I'll write out my negative 4, which is the power of 1, times x to the 0. And we know that x to the 0 is equal to 1. So it's negative 4 times 1, which then equals negative 4. So, yep, as you girls can see, the same rule still applies. That was a really good question, Lily. I'll skip to the next page. So what we've done so far, in our summary 1, just as I discussed, we used the quotient law and we showed that x to the 0 equals 1. And then in that next step, just before, we have shown that any number or pronumeral or integer in front of x to the 0 will equal that number, pronumeral, or integer. So I've just written this in pink for an example. If I had b times x to the 0, that would equal b because x to the 0 equals 1. All right, are we all good with that so far?
Yep.
Yep.
Great. Thanks, girls. So what about the 0 index with brackets? May look a little bit confusing, but don't worry, we'll go through it together. Our first example is 2h all in brackets to the power of 0. I first want to discuss, what does having the power up here mean? Does anyone have any ideas?
Doesn't it mean that the 0 pertains to everything that's inside the bracket? So
yeah, that's a great explanation, Nadine. So that means we would have 2 to the 0 times h to the 0, which I've written out here. And from our index laws, what do we know about 2 to the power of 0?
It's 1.
Yeah, and is the same for h to the power of 0?
Yeah.
Great, thanks, girls. So we know that that whole answer is equal to 1. So now it's your turn. I've got the answers under these blue boxes, but you can use the space in here to write out what you girls would think your solutions are. All right, great work. All of you got the same answer. You're really grasping this idea really well, that any number inside the bracket or any term to the power of 0 will always equal 1. Now, Nadine, it looks like I've got a question from you.
Yeah, so what actually happens if we have a term with the power that's inside the bracket? So, for example, like x to the power of 2 times y, all in brackets.
Oh, that's a great question. That's a great question. Let's do that one together as well. So your question was if we had
X to the power of 2
yeah,
times by y,
yeah,
all in
to the
brackets
power of 0.
0.
Okay, great. So our first step is to separate out the brackets to the power of 0. So that would give us our x squared. And then times, oh, that's a 0, sorry, times our y to the 0. And we know that our y to the 0 is equal to 1. And what about x squared to the power of 0? What does that mean?
Are we multiplying them together?
Yeah, so we know our power of a power rule means that we're going to multiply these together. And we know 0 times 2 is 0. So we're going to get x to the 0. And we know x to the 0 is 1. So that's 1 times 1, which equals 1. So to answer your question, Nadine, as I said before, any term, any equation, all inside the bracket to the power of 0 is going to equal 1. All right, nearly done. That's great. So on to our second last slide, little summary of what we just did. We just used our zero index law and our knowledge of expansion. We have shown that any equation, integer, set of pronumerals, all inside a bracket to the power of 0 will equal 1. And that's just that one there, and I've written it in words as well. So I'm just going to bring it all together, and I would like a class summary from you girls, maybe 1 to 2 points each on something that you've learnt today. Great, anything to the power of 0 is 1. That's a good point, and then just keeping in mind with that, using brackets or just x to the 0 or any pronumeral to the power of 0. When using brackets, the power outside the brackets pertains to everything inside the brackets. That's a really, really great point, and also a really great way of explaining what a power means when it's outside a bracket. And then I'm waiting for one more response. The same number divided by the same number is 1. Yeah, it's so interesting that some people don't recognize that, and some people also don't recognize that a fraction is division. So I'm really, really proud of you girls for everything that you've done in this lesson and for recognizing some really great ideas. And yeah, let's continue with the rest of the lesson.